morning. Okay. So, chemical kinetics only, that last part. Okay. So, last part we are going to discuss. Now, when it comes to the last part, based on Arrhenius theory, that means effect of the temperature on the reaction kinetics. So one problem they used to ask from that particular part, but anyway, so this time they have removed that one, so no need to worry, only theory part we are going to discuss. Fine. So hagadre when I am talking about Arrhenius theory, when I am talking about Arrhenius theory or Arrhenius equation, so which is based on the, or which talks about the effect of temperature. Effect of temperature. Effect of temperature on reaction kinetics. Effect of temperature on reaction kinetics. So that's what it's going to deal with. Okay. So what they have observed, what he has observed here is every increase of 10 degree in temperature, it's going to increase the, or it is going to increase the rate of the reaction almost doubles. Okay. So that's what he has observed, or in short we can tell, as there is an increase of the temperature, reaction rate of the reaction is also going to increase. So that's what Arrhenius theory talks about. So he gave an equation where rate constant is equal to, Arrhenius factor AE minus to the power of minus EA by RT. So this is the Arrhenius equation. So what is A here? A is nothing but Arrhenius factor or frequency factor. We can call it as frequency factor or Arrhenius factor. Okay, na? So what do you mean by EA here? EA is nothing but activation energy. Activation energy. So what is K here? All of us we know K is nothing but rate constant. So it should be small k. So K is nothing but rate constant. And R is nothing but gas constant. And T is temperature, under which condition that reaction is taking place. So that's where we have the Arrhenius equation. So where K is equal to AE to the power of minus EA by RT. So exponential, okay? So that's where K is nothing but rate constant, A is nothing but Arrhenius factor or frequency factor. So what is that frequency? Frequency of reaction, frequency of collision. So later this will be replaced by another letter in collision theory. Fine. So that's where K is equal to AE to the power of minus EA by RT. And EA is nothing but activation energy. Okay. So if I want to convert this one into normal logarithm, then I can write it as ln k. So whatever k is there will become ln k. Now ln a. Since there is an exponential, normal logarithm is to the base of e only. So therefore e to the power of minus ea by rt will become ea by minus ea by rt as it is. No need to write this e value. Okay. So therefore minus ea by rt. Minus ea by rt. So that's what this equation I have converted into normal logarithmic form. So ln k is equal to ln a minus ea by rt. That's going to mimic y is equal to mx. I will write mx on the other side only. So y is equal to c minus mx. Y is equal to c minus mx. Now, what is y here? Y is nothing but ln k. So, what is x here? X is 1 by t. X is 1 by t. Then, since there is a negative value minus mx, that means we should get the minus slope, negative slope. M is nothing but slope. So we should get this straight line, but where slope value will be minus. Slope is equal to minus Ea by R. Slope is equal to minus Ea by R, because whatever t is there, 1 by t, that will be taken as a x-axis. Okay, so what is that intersect on the y-axis? That is nothing but c. So value will be ln a. Value will be ln a. So by utilizing this particular graph, by using this particular graph, we can easily calculate the activation energy involved in that particular process. We can easily calculate the A factor, A value, by using this particular graph. All of you got the point? So that's where we have the application of the Arrhenius equation. So Arrhenius equation talks about, or it can be utilized to calculate the rate constant if we know the A value and activation energy value. If you know the E value, means A value and activation energy value, you can easily calculate the rate constant. Okay? Or if you know the rate constant, then you can easily calculate the Arrhenius factor, that is frequency factor, and activation energy value for a particular reaction. All of you got my point? Today I can see less attendance. Oh, YouTube effect. Okay, fine. So that's where we have the effect or application of Arrhenius factor. Fine. We have collision theory. Same way we have the collision theory. So when I am talking about collision theory, in the name itself it is there. When I am talking about the collision theory, in the name itself it is there. It talks about product formation will be decided by collision between the reactants. What is collision theory? It talks about rate of formation of the product will be decided by collision among the reactants. They have to collide, then only product formation will happen. As we have discussed earlier with respect to Arrhenius equation, same way here, rate constant is equal to Z e to the power of minus Ea by Rt. A is replaced by Z here. That's what I told. Arrhenius factor is replaced by Z here. That is nothing but collision frequency. That is nothing but collision frequency. How frequently those reactants they will collide with each other, because they will be present in the solution. So therefore, every time reactants may not be colliding with each other. Okay? So it is based on kinetic theory of gases. Collision theory, it is based on kinetic theory of gases. Kinetic theory of gases, because what it tells, kinetic theory of gases, It tells that gaseous molecules always it will be moving in all the direction. They are in continuous movement. Okay, so that's what it is based on the kinetic theory of gases, because even in collision theory it tells that in a reaction vessel where reactants are present, they will be moving, they will not be static, they will be moving here and there, and during that particular moment they are going to collide with each other. Okay, so fine, that's what collision theory talks about. So based on this, we can tell that even Arrhenius factor, it is nothing but collision frequency. That's what they did. They replaced Arrhenius factor with Z1. That's all. So what was the Arrhenius factor over there? That is the frequency of reaction. Frequency of reaction. So that will be decided by collision between the reactors. Fine. Any doubts with regard to this one? Now, this particular equation was further modified by adding another factor, that is probability factor. P is nothing but probability. Probability. So probability of what? Probability of effective collision. Probability of effective collision. Sir, what do you mean by effective collision? Effective collision means where whatever collision will happen, it should have the proper orientation. It should have the proper orientation. Then only product will be formed. If you go back to organic chemistry, haloalkanes and haloarenes topic. So we have discussed about SN1, SN2 reactions, right? So where we have methyl chloride. So we have methyl chloride which is going to react with OH minus or under basic condition getting converted into methanol. Getting converted into methanol. And another product will be chloride. Okay? So when I am talking about this particular reaction, if I focus on this particular molecule, I know that it will be having delta negative, delta positive. Dipolarity is there due to the electronegative character of the chlorine. Now, if the collision will happen in this direction, if this OH minus will start attacking in this direction, now what will happen? There will be repulsion will happen. Because negative and negative, they will repel each other. So when OH minus is approaching from this direction, no product will be formed. That's what we have seen. When you used to write the transition state, what you used to write? We used to show it like this. Right? So dotted line with chlorine, dotted line with OH. Right? That's what the transition state we used to tell. That means OH minus has to approach on the other side. It has to approach on the other side. That's where when OH minus is colliding with the carbon or methyl chloride on the opposite side of the chlorine bond, then that reaction will happen. If the collision will happen between OH minus along the carbon chlorine linkage, then it will lead to repulsion, no product formation. Okay, so that's where effective collision, that's where orientation factor. That's where orientation factor. Got my point? But anyway, collision theory, I think they have completely removed this one, but for your information, I have explained this one. Okay? So any doubts with regard to this one? But Arrhenius theory, okay, fine. If they ask definition also, you should be in a position to explain it. But problems will not be there. Okay? So no need to worry. Now next one is effect of catalyst. Effect of catalyst on the rate of the reaction. Okay? Naturally, if someone asks you, what will be the effect of catalyst on the rate of the reaction or chemical kinetics? What will be your answer? Pranati, Google Meet is best. Why? Many people they will prefer YouTube. Huh? My handwriting is not good on the board. You can be frank enough. No need to hesitate. I appreciate you told this one. Any problem if I am using Google Meet? Okay. Now I got the answer. We don't want to see your face, sir. Okay, simply I was making fun. Okay, not clear. So whether board is not clear, 1 minute. Okay, I was making fun. Now whether it's clear, Pranati? Whether board is clear? Oh, no. I think, can you rejoin it once again? Pranati? Yes, Sanjana. I am asking Pranati. Can you rejoin once again? Because I think here, even Krishna, he is using his tab only, where he is observing through internet only. It's clear, it seems. So can you rejoin? Okay. So we will wait for 1 minute. So I will tell effect of catalyst. So if anyone asks you, we will be waiting. I will be repeating the same. Pranati, you can rejoin fast. So when I am talking about catalyst, all of us we know that catalyst is going to enhance the rate of the reaction. Then why we have to study about the effect of the catalyst? That will be the questions, right? So when I am talking about Haber's process, nitrogen, hydrogen getting converted into ammonia. So in the presence of iron oxide, that reaction rate is going to increase. Right? Any reaction you take, you have studied many reactions in chemistry, right? First year and second year. In all those reactions, whenever catalyst is there, what is the intention of using the catalyst? To get the product in short duration. So naturally, catalyst they are going to increase the rate of the reaction. Then why we have to study about the effect of the catalyst? That will be the question. Right? Now here we are going to discuss exactly the mechanism, how this catalyst is going to function. Even in surface chemistry it is there. So therefore, try to focus on this. I think Pranati have joined. So when it comes to surface chemistry, there also you have discussed about the effect of catalyst. Fine. So therefore I am focusing here on the mechanism of action of the catalyst. Okay. So when I am talking about the catalyst, to understand the mechanism, first we should draw a graph. Okay, where on the y-axis it will be energy. On the y-axis it will be energy. Okay, and on the x-axis it will be time. On the x-axis it will be time. So when you plot the graph for any reaction you take, where reactant is getting converted into product. After some time, whatever reactant is there, it will get converted into product. Now, if I consider reactant, its energy is somewhere here, because all of us we know that each and every molecule they have their own internal energy. Each and every molecule they have their own energy. So with that particular concept, if I take reactant, its energy is somewhere located on this particular line, somewhere here. Now, as the reaction proceeds, when these reactants, they are going to collide with each other, they will move to higher energy. When reactants, they are going to collide with each other, they are going to move to higher energy. And since anything at higher energy, they should be temporary. They should be unstable. It's very simple. Always I'll be telling to my students, you hold your hand where all the fingers are closed, right? We have utilized the energy. To move the fingers, we have utilized the energy. Now, I can challenge you that unknowingly within 5 minutes your hands will become open, your fingers will open up. Until unless sir has told we are going to lose the game. So we will hold the hands, our fingers like this. If you focus, then only it will be like that. Otherwise, automatically it will get open up. Right? So that means when I am holding my fingers like this, it is at higher energy. When I am releasing my fingers like this, it is under relaxed condition. That means lower energy. So what I mean to tell you is, whichever is at higher energy, they should be unstable. It's a temporary state. Okay? So immediately they will come to lower energy state. It will come to lower energy state. Now, if you observe, reactant position is somewhere here, and this is related to product. So its energy is somewhere here. Product, its energy is somewhere here. Which is at higher level, reactant or product? Or you should tell me which is of higher energy, whether reactant or product. You can just mention R or P. Which is at higher energy according to this graph? Which is at higher energy, reactant or product? So naturally it should be reactant. Absolutely correct. Reactant is at higher energy level compared to product. So therefore, I am talking about a spontaneous process. Where molecule is from higher energy, it is getting converted into lower energy. I am talking about a spontaneous process. All of you got clear? So when product is at lower energy compared to reactant, naturally it should be a spontaneous process. Now what about this one, sir? What is this? This is nothing but transition state. If you go back to organic chemistry, just now, 5 minutes back, I have discussed transition state with respect to conversion of methyl chloride to methanol. If you recollect, you used to write the transition state like this. Dotted line for chlorine, dotted line for OH, and we used to write that one in a square bracket to make it very clear that it is a transition state, temporary state. Got my point? Same way, all the reaction it will happen. But you are mentioning this particular transition state for SN2 type of reactions. For others, you are not mentioning, that's it. But that doesn't mean that in all the other reactions, no transition state will be formed. No. All the reaction, it will happen through the transition state only. They cannot happen directly like this. They have to go to transition state because they will be colliding with each other. Okay, now? So that's where we have the transition state, which is at highest energy. Transition state is at highest energy. Therefore, it is a temporary. And due to the attainment of transition state, product will be formed. Otherwise, it would have been impossible. Okay? Now, whatever I have shown the graph, whatever line is there, it is in the absence of catalyst. It is in the absence of catalyst. Okay? Whatever I have shown the graph, it is in the absence of catalyst. Now, if I am using a catalyst for the same reaction, if I am using a catalyst, I will see if possible I will use different ink for this. So once again we have the reactant. Once again we have the reactant getting converted into product in the presence of the catalyst. In the presence of the catalyst. Whether you can see whatever I have written. Reactant getting converted into product. But in the presence of the, they will be watching video. In the presence of the catalyst. Now what will happen? We are going to have the similar pattern of graph. We are going to have the similar pattern of graph. We are going to observe the similar pattern of graph, but there is a difference. But there is a difference. But there is a difference. What is that difference? Can anyone of you tell me? What is that difference? So this is also transition state. Okay? Presence of catalyst. Presence of catalyst. So what is that difference? All of you can observe. What is that difference? Dheeraj has written reactant. Krishna, energy of activation is reduced. I never told energy of activation. From where you got the point? I have not written energy of activation. But you are right, absolutely correct. Energy of activation only. But before that, I want in some other term. Based on the graph, you can tell. Energy of activation is absolutely correct. No doubt. So formation of transition state is fast compared to first one. Okay, fine. What is the reason? What is the reason? Formation of transition state is fast. Okay, I agree. What is the reason? Based on the graph, you can analyze the graph and you can tell me. Based on the graph, you can tell me. Whatever you people told, whatever Krishna or you told, it's both are correct only. Time, sir. Okay, Pranati. If I say time is same, both are having same time period, no change in the time period, whether it is the presence of catalyst or whether it is in the presence of absence of catalyst. Period in the sense, sorry, I can tell this is related to not time, with related to reaction. Okay, fine. I have removed the time. Presence of catalyst enhance the rate of the reaction. Now I will tell. Whatever you are telling, it is absolutely correct. But I have removed the time. It will be wrong concept. I have removed the time. Okay, fine. It is the reaction process. Okay. Now, when I am talking about this particular thing, I can see that transition state has moved to lower energy. If you see the y-axis, transition state is at lower energy level. Or, as Krishna has told, whatever reactant is there, this is the base level for the reactant. From reactant, it has moved to the transition state. That's where we have the activation energy. That's where we have the activation energy. Okay? Same way, in the presence of the enzyme, from base level, transition state is there. Now that's where we have the activation energy. That's where we have the activation energy. So what I mean to tell here is value of activation energy is less in the presence of the catalyst and value of activation energy is high in the absence of the catalyst. Okay, so what do you mean by activation energy? Activation energy is nothing but amount of energy required to attain the transition state by the reactants. So what do you mean by activation energy? Activation energy is the amount of energy required to attain the transition state by the reactants in a reaction. That's where we have the activation energy. So that activation energy is less in the presence of the catalyst and that activation energy will be high in the absence of catalyst. That's all. Okay, and that's how a reaction will be a bit faster in the presence of the catalyst because activation energy value is getting decreased. Transition state will be formed fast, so therefore product will be formed fast. Got my point? That is the effect of the activation catalyst on the activation energy. So I can mention that catalysts will decrease the activation energy value. Will decrease the activation energy. That is one particular point related to catalyst. They are going to decrease the activation energy value. Got my point? Whether I am clear? All of you have understood? Now that is one thing. And I told this reaction is a spontaneous reaction. Why? Because the reactant is at higher energy level and product is at lower energy level. Now another important statement I will give related to the catalysts. Catalysts will prefer to catalyze the reaction. Catalysts will prefer to catalyze a spontaneous reaction. A spontaneous reaction. Okay? A spontaneous reaction. That means a non-spontaneous reaction cannot be catalyzed by a catalyst. Many people, they will think that, oh, catalyst can catalyze any reaction. No. It will catalyze only those reactions where product will be at lower energy compared to the reactants. Reverse will not happen. Reverse will not happen. That's where we have another important character of the catalyst. One is they are going to decrease the activation energy. That is very important. So what do you mean by activation energy? Amount of energy required to attain the transition state. So what is that next character of the catalyst? They are going to prefer to catalyze the spontaneous reactions. That is another important point. And the last point, whatever I will be mentioning, you people have studied in your first PU chemical equilibrium topic. Whatever the last one I am going to tell, that point you people have discussed in your chemical equilibrium topic. So that is catalysts will not alter the chemical equilibrium value or chemical equilibrium constant. It's not going to alter the chemical equilibrium constant. Then you might be having a question that then what the hell catalysts are doing then? Now the catalyst will be decreasing the duration or time to attain that equilibrium condition. Catalyst helps in attaining the equilibrium. Helps in attaining the equilibrium. Attaining the equilibrium in short duration. In short duration. What my point? They are not going to alter the equilibrium constant value, but they helps in attaining the equilibrium in faster rate. That's how a catalyst is going to enhance the rate of the reaction. Okay? That's how the catalyst is going to enhance the rate of the reaction. Now, my students, I know questions will not be there, right? Any doubts? But I have a doubt on my own statement. Doubt here, in that case, sir, if I am having nitrogen and hydrogen getting converted into ammonia, right? So if that is the case, nitrogen, hydrogen will get converted into ammonia and ammonia will get converted into hydrogen and nitrogen. Then what is the use, sir? After some time it will reach to the equilibrium where some amount of ammonia will be there and some amount of nitrogen, hydrogen will be there. Then what is the use of using the catalyst? That is iron oxide. What is the use? Okay, so iron oxide will be used to make these reactions to happen a bit faster. That's fine. But not to make these reactions to reversible, we are providing other conditions like high pressure, high temperature. We are providing the other conditions which will make sure that this reaction should be in one direction. That means towards the formation of ammonia. It should not convert it back to nitrogen and hydrogen. So that's where you should appreciate the chemical equilibrium concept. You should appreciate that one. In everyday life, in day-to-day life, we can observe those phenomena. This is the reaction which will be utilized for the preparation of ammonia. I am opening an industry where I want to have the ammonia as much as possible so that I can use those ammonia to synthesize the fertilizer, that is urea. Now if that is the case, I don't want to have a loss. I will be opening an industry to make the profit, no doubt. So that means if ammonia is formed and it's getting converted back to nitrogen and hydrogen, I will be under loss. So to avoid that, along with the iron oxide, we are also providing the condition. That's what in P block elements you people will have been mentioning. Yes, Krishna has written Lee-Chatler's principle. Yes, they will be providing the pressure so that a reaction has to move to that direction where less gaseous molecules are there. Right? So if you observe on the left hand side, 4 gaseous molecules, 3 hydrogen, 1 nitrogen, but on the right hand side, only 2. So we are providing the pressure so that always ammonia should be formed. That's where Lee-Chatler's principle we are applying here. Got my point? So don't get confused. Iron oxide is not the one which will make sure that ammonia, all the nitrogen and hydrogen should be converted into ammonia. No. It is the other conditions which will make sure that ammonia has to be formed and it should not be converted back to nitrogen and hydrogen. Okay? All of you got my point? Any doubts with regard to this one? For competitive exams also they will ask based on these concepts. Anyway, activation energy definition and all, it's not there, I think so, because they have removed that one. But any doubts? Whatever concept we have discussed, any doubt? If you have any doubt, you can send a message. So by this, chemical kinetics, whatever revision was that, it is done. Okay now? So try to focus on, when it comes to chemical kinetics, since some of the portions they have removed, especially collision theory and Arrhenius theory, means especially mathematical form. So since all those concepts has been removed, from chemical kinetics, definitely are going to have the problem related to half-life. Otherwise, they had an option. Either it is from temperature, effect of temperature on the reaction. From that part, they used to ask the problem, or from the half-life. Now, since other part is deleted, from the half-life you can expect the question. So what I mean to tell here is, if I want to target 3, 4 and 2 marks, repeatedly I am telling, I am not talking about the 1 mark question. 1 mark question, anything they can ask. Okay, but 3, 4 and 2 marks, we have to focus on derivation. Okay, so derivation related to rate constants. Okay, derivation related to rate constant, zero order and first order, integrated rate constants equation. So another derivation related to half-life. Another derivation related to half-life. So 3 or 4 marks will be covered here and 2 marks will be covered over here. Okay, fine. Now, what I mean to tell you is, anyone from this, not all the things, anyone from this. Then, if they are not asking on half-life, only one from this one, derivation, then another question or problems based on half-life, we can expect. Based on half-life, we can expect. Once again for 2 marks. Okay. Now naturally, when it comes to 1 mark, try to focus on SI units. SI units for rate constants. Okay, SI units for rate constants and many other definition and all, whatever we have discussed. But one question from this part, 100% it will be there. Any one derivation, one question, 100% it will be there. Every year they have asked. Okay, so try to practice and don't forget to put the graph at the end. When you are deriving the rate constant equation, don't forget to put the graph. Okay, so that's where chemical kinetics topic is finished with respect to the revision part. If you have any doubts, you can ask. Okay, so in that case, I will give a brief introduction about new topic, very, very important topic, that is aldehydes, ketones and carboxylic acid. Carboxylic acids. Very important topics related to your board exam also, competitive exam also. So try to focus on this particular topic, because in the organic chemistry or from the organic chemistry, this chapter is having maximum weightage. I'm not telling other chapters they don't have, comparatively I'm telling. Okay, so that's where we have aldehydes, ketones and carboxylic acids. Fine. So nearly 8 marks, 8 to 9 marks you can expect from this particular chapter. When I'm talking about this particular chapter, that is aldehydes, ketones and carboxylic acid. So what are those? Naturally, these are the organic compound having. That means this chapter is going to deal with the property of those organic compounds having aldehyde, ketone and carboxylic acid as their functional groups. carboxylic acids as the functional groups. Right? They should be having, or we are going to study those organic compounds in this chapter. We are going to study those organic compounds which are having aldehydes or ketones or carboxylic acids as their functional groups. Okay? Now, what do you mean by functional groups, which you people have studied in your first period? Basic concepts of organic chemistry. What do you mean by functional groups? Right? So this is related to this chapter. So what do you mean by functional groups? So functional groups are the part of organic compounds, part of given organic compound which is going to decide the property of the element, especially chemical property, which will decide the property of given organic compound. That's where they will be called as functional groups. That's where they are called as functional groups. So here we have only three. And already people have studied about alcohols, phenols, ethers. Even they are all considered as functional groups. Amines. Even amines will be considered as functional groups. Right? So that's where we have the definition for the functional groups. Okay, so what do you mean by functional groups? They are the part of the given organic compound. They are not separate entity. They are the part of given organic compound which will decide the property of that particular organic compounds. Okay, so that's where we have the aldehydes, ketones and carboxylic acids as three major functional groups. Even in biomolecules, if people have studied about aldehydes and ketones, sugars will be named based on aldehydes and ketones. Glucose is called as aldose because it's an aldehyde group containing sugar. Fructose, they are called as ketones. Why? Because they are ketone group containing sugars. But here in this topic we are not going to focus on carbohydrates. We are going to focus on all the other organic compounds other than the carbohydrates. Okay? So when I am talking about aldehydes, if someone asks you to write the structure of aldehyde functional, so naturally you are going to mention like this. In Viva Voce, they will ask sometimes. Okay? CHO. If you write like this, if I am the examiner, I will give 0 marks because it is wrong. Okay? So we have to show it one line. Because if I explain it further, molecule can be written, can be written like this also. So what is the valency of carbon? 4. So 1, 2, 3, 4. If I write like this, what it means? It means I am showing the functional group like this. What is the valency of carbon? Only 3. This is wrong. Okay? So therefore, one line should be there. So what this line indicates? This line indicates that there is another carbon to which this aldehyde group is attached. So there is some carbon is there to which this aldehyde group is attached. So therefore, we can mention that one as R. Or if they ask simply about the aldehyde group, even no requirement of R also. You can show it like this. That's understood that you are talking about aldehyde group attached to a given organic compound. Okay? Same way. If I want to talk about ketones, so we can mention like this. or we can mention like this. In both the cases, we are dealing with the ketones. In both the cases, we are dealing with the ketones. Now, last one, carboxylic acid also I will write, then further I will explain. So when I am talking about carboxylic acid, then we can write like this, or we can write like this. Once again, many students, they will make the mistake. Carboxylic acid, they will write like this, and they think that they have written a proper and correct answer. No, that is wrong. We have to show this line to indicate that carbon is saturated. With all the four valency, carbon is saturated. Okay? So that's where we have the carboxylic acids, ketones and aldehydes. Okay? Right? Can any one of you tell me what is that common in all these three? Can any one of you tell me what is that common in all these three? Okay, CHO. Okay, Brinda, in all of them they have carbon, hydrogen, oxygen. Okay, fine, very good. So they are having carbon, hydrogen, oxygen. Fine, done. I accept it. Double bond, oh yes, this is what I was expecting. Yes, very good. So all of them, they are having a common feature, that is carbon with the double bond. What is this? When I am focusing on only on this one, not as a functional group, then I can call them as carbonyl groups. Then I can call them as carbonyl groups. If carbonyl group, if it is acting as a functional group, then it will become ketones. Then it will become ketones. Okay? So common in all these three functional groups is they are having ketones. Carbonyl groups. All of them, they are having the carbonyl groups. Absolutely correct. No doubt. All of them, they are having carbonyl groups. Any other common feature in these three? This is one. Okay, this is one. This is second one. Anything else? Answer is here only. Anything else which is common in these three? In fact, first point itself answer is there. Okay, double bond. Okay, fine. A valence of carbon is left. Means what? All the valence is saturated. That's what I am telling. No valence is left. Here other carbons will be there. No doubt. Okay. That common one is all of them, they are having carbon in their structure. All of them, they are having carbon in their structure. As she told, Brinda, she has told. They are having carbon, hydrogen, oxygen. So all of them, they are having carbon in their structure, which can be the part of parental molecule. Which will be the part of parental molecule. Carbon in their structure. Which will be the part of parental molecule. While naming the molecule I am talking about. Okay? So these are the common features with respect to these functional groups. What is that difference then? There should be difference, right? Therefore, they are all different molecules. Aldehydes will behave differently compared to ketones. Ketones will behave differently compared to carboxylic acid. And they will be having some of the common feature also because this common character in their structure. But they are different functional groups. They are different molecules. So then what is that difference? Anyone? Yes. Here.
connected it to the Wi-Fi. That's all.
Okay. So now carbon is connected with another carbon, then hydrogen. Aldehydes and carbon appears at the last while ketone in the middle. Yes, Purnima, very good. Anyway, I will come to that point, but very good point. Very good point. Okay, now? So here, carbon is a carbonyl carbon. I can use the better term. Carbonyl carbon is attached with hydrogen and other carbon. But in carbonyl carbon, in ketones, they are attached with the two carbons. No hydrogen. They are attached with the two carbon. Here carbonyl carbon is attached with one carbon and one hydrogen. But for ketones, they are attached with the two carbons. But when it comes to carboxylic acid, carbonyl carbon is attached with hydroxyl group and carbon because there is R. So here also I will make it as R. So that's where they differs, carbonyl group differs with surrounding molecules. They are having different surroundings. Carbonyl carbon, they are having different surroundings. Here it is hydrogen and carbon. Here both are carbon. Here carbon and hydroxyl. I will not call it as alcohol group because when I will call it as an alcohol, I am talking about the functional group. No, it is not a alcohol functional group. It is a carboxylic functional group. Sir, they all can give 2,4-DNP test. Okay, they will give. Yes, no doubt. That's what? That is due to some common character. That is due to the presence of carbonyl group. They will show some of the common reactions, but even they will show different property also. They will show different properties also. That is because of the different surroundings. But as you told, yes, that is because due to the presence of carbonyl group. Okay? Anyway, I will stop here. If you have any doubts, because from Monday we are going to continue with aldehydes, ketones and carboxylic acid. Even you can inform to your classmates also. Even they can join the class. New topic it is. It's not a revision. Okay? Any doubts? Okay, then, if you don't have any doubts, Archit, yeah, okay, done. So, any doubts? So, in that case, I will stop here. Thank you, take care. We'll meet on Monday. Fine? Thank you.